All right. We have the question that say using EZ system of nomenclature, give the structures. 1,2-dichloroethene, 3-isopropyl 2-ethene, 3-chlorobutanoic acid, and 1-bromo 2-methyl 1-butene. Now, whenever we talk about the E and Z nomenclature, the E and Z nomenclature was given by Can Ingold Prelog to actually name compounds that are different from the normal cis and trans isomers of alkene. Now, before you be able to name any compound using the E and Z nomenclature, this you may decide not to answer it in the theory, but you can't escape it in the what? In the objective. 1,2-dichloroethene. It's almost impossible. Okay, let's see. 1,2-dichloroethene. Now, firstly, you have to draw the double bond. That is the first thing I will admonish you to do. Draw the double bond, which is carbon-carbon double bond, because you know any alkene have a carbon double bond. Now, dichloroethene. Now, it means at position number 1 and 2, you have chlorine group. So you have chlorine group here. You have chlorine group here. Are you getting it now? Then the next thing you have, how many hydrogens are needed for us to complete the nomenclature? You have 1 hydrogen next. Are you getting it? To add to complete the nomenclature. So you have hydrogen and then you have hydrogen. This is the structure of 1,2-dichloroethene. Now, this structure you see like this. You can use cis and trans. But if you want to use the E and Z nomenclature, this structure here is the one that have the highest priority. Now, before that, let me just teach you how to use the E and Z nomenclature. First of all, you divide this into 2. Consider them based on the one that have the highest priority. These have higher priority compared to this. So this will be A, and here will be B. Now, also here have a higher priority compared to this. Why? Because chlorine have a higher atomic number compared to what? Hydrogen. Right? So this one, when the 2 high priority group are on the same side, you call it the E configuration. So this compound now, the name would be E. You call it the Z configuration. When the 2 higher priority group are on the same side, you call it Z or Susame. So this is Z 1,2-dichloroethene. All right. So this is for the Z configuration. Are you getting it now? Now the next one is you can still draw it like this. They are the same thing. Are you getting it now? But in this case, if you look at it, here A is not here, B is not here. Then here B is here, A is here. So when the A and B are on opposite side, you call it the what? The E configuration. So that is where you now come here and name this as what? E, 1,2-dichloroethene. So that's basically how you draw the structures for each of them individually. So for the first one, you draw the Z, and for the second one, you draw for the what? E. Now, what I mean is when the 2 high priority group are on different sides, this one is facing up, this one is what? Facing down. Are you getting it? You call them what? N-Gengen or E configuration. All right, so that is that for the first one. Let's see for the other ones. 3-isopropyl 2-heptene. So the first thing I told you now is to draw the structure, the carbon-carbon double bond. So we are going to call me a carbon-carbon double bond. 3-isopropyl 2-heptene. Now, this 2-heptene is telling you that it is at carbon number 2 that you have the double bond. So what we are going to do here, it means we also have CH2, CH3. Or let's say CH3, CH2. This one is telling you that this is what? 2-heptene. Are you getting the no. You're supposed to be just hydrogen. Now what this one is telling you, listen, is that at position number 2, that is where you have the double bond. That is why you have it as 2-heptene. So having drawn the carbon-carbon double bond, you are now going to add 1 CH3 so that it becomes 1, 2. You have the double bond. And then at position number 3, what do you have? isopropyl, which is 3 isopropyl. So if here is 1, here is 2, here will be what? 3. Are you getting it now? So at position number 3, you have the isopropyl present there. So what we are going to have here is something like this. Let's say you have isopropyl is something like CH and then CH3, CH3. This is the structure of isopropyl. Is that okay? This is the structure of isopropyl. At position number 3, that's what you have. And then to complete the heptene, what do? This is already 1, 2, 3, and then you continue 1, 2, 3. You add 4 of CH2 to it. CH2. The space will not be enough. To get only this structure, don't discourage some persons from answering this particular question. Alright? CH2, somebody like me, if I will leave them. And then we have what? CH3. This is the structure you expected. So if you want to arrange it in a way that you actually name it, in a way that it will be easy for you to name, all you need to do is to first of all write C, double bond C. This carbon here, what is attached to it? First of all, you have hydrogens attached. So you have hydrogen and then you have CH3 attached. Now, how about this other one here? This other one, you have CH3, CH2, CH2 attached. So I can come here and then take this one. These things are not as hard as this one. I don't know why person go bring this kind of thing come for exam. If you count 1, 2, 3, 4, 5, 6, 7 is correct. So this will give us CH2, CH2, CH2. I love it when you bring it out, but you can shorten it by just saying CH3 bracket 3, then CH3. CH2 bracket 3, then CH3. And then this other one, you have it as CH. Then you have this thing added to it, 2 CH3 attached to it. So I've written the CH, you have CH3, and then in bracket 2. And then this other one here, you can write it CH2, CH2 into 3 places, and then CH3. Are you getting it now? So this one will be CH2. You can put it like this, and then put this other one CH. What I mean is this other one can be CH2 into 2 plus this one making it 3, and then this last CH3. This is the structure you are expected to draw. And then so you should use the E and Z configuration to name it. So all these ones you have here, you can delete them now. Like I told you, you may not escape this in the objective, but you can escape it in the theory. Alright? And these are the kind of questions I saw in that Umbra's listing the other day when I was trying to look at it. So you have something like this. They may give you the structure, they will just say name it. If you divide this into this, now high priority, of course, CH3 have a higher priority than what? Than hydrogen. So here will be A, here will be what? B. That's just it. Now when you come here, which of them do you think have a higher priority? Now this thing you see here, it means carbon bonded to hydrogen. Are you getting it now? Carbon bonded to hydrogen, then bonded to another carbon. That is the meaning of what you have here. If you want to bring it out, it's more like this. Let me show you. Carbon bond to what? Hydrogen. Then when you come here, this carbon bonded to what? Another 3 hydrogen. And then this same carbon bonded to 3 hydrogen. That is the meaning of the structure you have here. Carbon bonded to first hydrogen. Then this other carbon that was attached bonded to 3 hydrogen. You know there are 2 CH3 here. Another carbon bonded to 3 hydrogen. So this is what you have. Now what about here? What you have is carbon, hydrogen, hydrogen. Now, if you look at it very well, this first one here is carbon, hydrogen, carbon. Now, which of them do you think will have a higher priority? If you look at it, carbon have high priority. Both of them are the same. So you cannot use this carbon to measure. You cancel. Then when you come here, hydrogen, hydrogen, you cannot use this hydrogen to measure. So you cancel. Then you now consider this carbon and this hydrogen. This carbon have a higher priority than this hydrogen. So this one here will be your A here, and this one will be your B. So this structure this structure now will be the two high priority group are on different side. I can come here and name it as what? E, because they are on different side. E isopropyl, right, 2-heptene. Now, how about for Z isopropyl 2-heptene? It means the two high priority groups should be on the same side. So I'm going to have something like this: C, double bond C. What I'm going to just put is CH3 here, then put hydrogen here. Then this other one will still remain the same, CH2, and then we have CH2 bracket 2, then CH3, and then this one you have CH3 bracket 2 CH. If you look at this very well now, this is A, this is A, this is B, this is B. Two A's are on the same side. Now you must not do this in the exam. I'm just trying to show you how you can visualize it. So this gives us Z isopropyl 2-heptene. Alright, so that is basically that for this question. Now let's see another one. 3-chloro-but-2-enoic acid. Now firstly, you have to draw what? Carbon-carbon double bond. That is what I said you should draw first. Now 3-chloro-but-2-enoic acid. Now what does that mean? It means that at position number 2, that's where you have the carbon atom. Then you have the carboxylic acid group. Of course, you know, when you are naming carboxylic acid, it must start from carbon number 1. So it means that this carbon here is carbon number 1. Here will be 2. So this is more like the but-2-enoic but-2. We have not completed but this prop. So to make it but, you add CH3 here. Are you getting it now? So it's not complete, but-2-enoic acid. Now you have hydrogen here. At what position do you have the chlorine group? Position number 3. So you have chlorine here. This is the structure. Are you getting it now? You just use brain and formulate the structure out. If you count, this is number 1, 2, 3, 4, which is 1, 2, 3, 4. This particular one now, carbon is how many? 4, which is butanoic acid. Now, at what position do you have chlorine? Position number 3. So you say this 3-chloro-but, because it's 4. Position number 2, that's where you have the double bond, 2-enoic, because of the carboxylic acid. Now, how do you rearrange it in the nomenclature form so that it become easy? I can decide to have this one here and hydrogen, and I can decide to have chlorine here and CH3. This is how it's going to look like. Alright, now you have something like this. Name it now, this first one, using the E and Z nomenclature. First, divide this into 2 with your invisible I. Chlorine have higher priority than carbon, because this thing, what it means is that carbon is bonded to hydrogen, bonded to hydrogen. That is the meaning of this. If you want to write this structure, you say this is carbon bond to carbon. Then you have hydrogen, hydrogen, hydrogen. That's the meaning of this CH3. Then this carbon bonds to chlorine. Then you have double bond, and then you have this carbon bonded to oxygen, bonded to oxygen, and then you have what? Hydrogen. Do you understand? So if you want to consider, it's now between this carbon directly bonded to this carbon, and then this chlorine directly bonded to carbon, and carbon directly bonded to this carbon. Between them, which of them have the highest atomic mass? These have higher atomic mass compared to this. So here will be A, here will be B. Now, carbon and hydrogen, which one have the highest atomic number? Here will be A, here will be B. So what configuration is this one? This is the Z configuration, because it has the two higher priority group on the same side, A, B. So you come here and say the name of this compound is what? Z 3-chloro-but-2-enoic acid. Alright? And then you have this one, bromo 2-methyl-1-butene. You come here and say this is bromo 2-methyl. Right? Now, firstly, you have to draw your carbon-carbon double bond. Now, butene means, have you drawn your double bond? The next thing is to add carbon, because you have to know where the double bond is. The double bond is at position number 1, so it means the double bond will be somewhere around here. So at this point in time, you can start putting other carbon atom. If you say the double bond should be here, so it means here will be H2. Let me just put it like this, and then you start adding your other carbon to make it butene, which is 1, 2, 3, 4. At position number 2, what do you have? Methyl. So here you have CH3, which is methyl. Are you getting it now? And then butene is correct. Bromo, 1 bromo, 2 methyl butene. So it means at position number 1 you have bromine group. So one of these hydrogen will be substituted with what? Bromine. So you have something like this. And then of course the next thing is this. So this is the structure you are expected to draw. 1 bromo, right? At position number 1. If you start your numbering from here, here will be number 1, here will be number 2, 3, and 4. So this is 1 bromo, 2 methyl. Are you getting it now? But 1 in or 1 butene. 1 bromo, 2 methyl, but 1 in or 1 butene. Now if you want to draw it in the, have I drawn the Z configuration for this one? Did I draw the E configuration for this first one? If you want to draw the E, I don't know if I've drawn it, but let me just draw it. The E configuration for this one will be carbon-carbon. I don't know if I've drawn it. OOH. Are you getting it? And then you have CH3 here. Here it become chlorine. And here become what? H. Higher priority A, B, A, B. 2 higher priority group are on the same with different sides. So you say E, 3 chloro, 2 butanoic acid. Are you getting it? I don't know if I've drawn it. That's the reason why I think I've drawn it, but my spirit is telling me that I did not draw it. So that was why I have to do it again. Alright, so with this structure now, let's now bring it out and put it in normal way. This carbon here, you have these 2 carbon as central carbon. This is what you have here, bromine. This one here, what do you have here? Hydrogen. This one here, what do you have here? CH3. This one here, what do you have? Because you are now looking at what is directly attached to this carbon at the double bond. That is what you are looking at. So this gives us CH2, CH3 to complete it, butene. So this is the structure. Now, which of them is this, E or Z configuration? We are going to look at it critically and analyze it. This is A because this one have higher atomic number compared to this B. This is what? Now, when you look at straight chain and cane, the one that is longer have higher atomic number. Straight chain, I didn't say branch, straight chain. The one that is longer have higher priority. So here become A, here's what B. For straight chain, I didn't say branch. Because if you analyze this, this is CH, H, H. That is the meaning of CH3. Why this one is what? CH, H, which is CH2, then another C, H, H, H. If you cancel, C cancel C, H cancel H, H cancel H. Then this H now is competing with this carbon. Between this H and this carbon, which one have higher priority? The carbon. That is the reason why here is here. Now, at this point in time, what configuration is this? According to what we have learned, this configuration is E, 1 bromo, 2 butyl, 1 butene. 1 bromo, 2 methyl, 1 butene. So that is that. Now the next one is the Z configuration, which becomes C double bond C. Here's what? CH3. Here is CH2. CH3. For the Z, the 2 high priority group must be on the same side. So I can have hydrogen here. Here is Br. So here is A. Here is B. Here is B. Here is A. So this is Z configuration for this compound. That will give us Z1 bromo, 2 methyl, 1 butene. So you may not escape this in the objective, but you can decide to escape it in the theory. That is the reason why I have to do it. Right? So basically that is that for this lecture. Thank you very much for your time. We'll see you in the next one. Bye.